HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 384, recorded live Thursday, August 8th, 2013. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Dino Viehland about Python tools for Visual Studio.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and on the phone I've got Dino Viehland from Microsoft. How's it going?
Good. How are you doing, Scott?
Very well. You have been doing Python at Microsoft, like as a full-time job. You're a dev for how many years?
It's been about 7 so far.
So why does Microsoft have a Python person on staff, and how are they letting you do this for 7 years?
Well, it started with IronPython, which was an effort to get Python running on .NET. And, there was a lot of interest in .NET, and there wasn't a really great scripting story for .NET. So Jim Huguenin started off initially trying to prove that .NET wasn't a good platform for doing dynamic languages, and ended up proving the opposite. So shortly after doing that, he came and joined Microsoft, and I was on the CLR team at that point in time. And shortly after he joined, I switched to IronPython, which was also being incubated inside of the CLR team. Mm-hmm. And that was my first experience with Python, and so I got to learn it by implementing it. And it was a lot of fun, and so I've stuck with it since then in one form or another.
Were you a Python fan like before?
No, I was actually scared away by the significant white space, which is really not an issue at all.
That was your fear. Like of all the things you could be afraid of, it was white space.
Yeah, I mean, it just seemed kind of crazy to me at the time, and that was just my own ignorance. I was very used to the squiggly brackets in my code, and this is crazy. It's all based upon white space, and so I never really gave it the time of day. But it seemed really interesting from a language implementation perspective, and that's what drew me to it initially. And and now I love it.
Mm-hmm. The team is pretty small, though, right? Like, there's not a lot of people over there.
Right. So, working on PTVS today, we have 4 developers and 2 testers and 1 PM. So it's not a big team, and we actually split our time between PTVS and some other efforts that we occasionally work on.
Mm-hmm. Is this under, like, I want to get a sense of this, right? Like, is this under the radar? Are you guys doing something you shouldn't be doing and just no one has noticed yet?
No, I mean, our management is aware of what we're doing, and we try to tie in what we're doing into our overall efforts. So it's not a complete skunkworks project or anything like that.
Mm-hmm.
They support us, and, in return, we try to support their efforts too.
But give me some historical context, because I remember that, like, when John Lamb and the DLR folks were all off doing dynamic language runtime, there was this kind of like excitement around Iron Ruby and IronPython.
Yep.
And then this is what people would say, and I'm kind of speaking for the public, like, and then Microsoft killed them all and declared these languages suck and we'll never support them, and then fired everyone, and the team was disbanded and cut into small pieces.
Well, we didn't entirely kill them. It's more like we released them to a farm-up state, right? We worked with the community, and we got several key players involved, and we handed off IronPython and IronRuby to the community in a way that, they continue to evolve. IronPython, in particular, saw a huge amount of immediate benefit when we released it, because there was a bunch of stuff. We weren't taking contributions back to the project because there's always this concern of, well, we might want to ship it in the box somewhere, and people were nervous about that. And so there was a bunch of pent-up work that could easily just flow into the project. So it saw a bunch of immediate benefits.
What's the difference though between like releasing it to open source because we want to kill it and just throw it over the wall versus like making it open source and having it continue? Because it seems to me, and do correct me if I'm wrong, that IronPython is doing pretty well. It's quite healthy. And IronRuby though is kind of chilling. It's not really doing much.
Yeah, it definitely didn't get quite the same amount of interest in it. I think that is just kind of IronPython was a little more mature. IronRuby is also, Ruby is a more challenging language in itself. So while IronPython, it showed some great performance benefits over CPython, Ruby, that was always more challenging. So that might have had something to do with it as well. And there's just the fact, I think Python probably gets more broad adoption than Ruby does as well. It's used in a bunch of different areas, whether it's web development, which Ruby shares, or whether it's technical computing, or any other number of areas where people are actively doing Python development, and there's a huge amount of libraries for those other areas. So I think it's just a little more mature than Ruby, and that probably helped it out as well. But they both, to a certain extent, suffered a little bit longer term. It helps when you have people who are working full time on them. And there's no substitute for that. So there's pluses and minuses. I think the nice thing about it is that it really changed the way that Microsoft focused on Python. And so we are very focused about taking Python and getting it running on .NET, which is on our platform. And that's interesting to a lot of people. But if you look at what the bulk of Python developers are using, it's actually CPython. And so kind of moving to CPython and embracing the Python developers where they're at, I think that was, despite the hecticness of having your project canceled, I think it's a good long-term outcome. So
when you say canceled, that means that Microsoft was no longer going to pay people full-time to work on IronPython and IronRuby.
Yes, exactly.
And instead, you're saying that they wanted to see if they would kind of exist on their own? And the Ruby community was just like, don't really want Ruby on the CLR.
So I wouldn't say that Microsoft really wanted to see if they would exist on their own. That wasn't really the reasoning, right? The reasoning was all about resources and where do we want to allocate our resources. And so it happened that the team that I was on, they were feeling a bit of a crunch resource-wise, and so it was kind of what goes. And it wasn't like that team then picked up and started doing other Python development. I actually went and joined another team to start our Python tools for Visual Studio effort. So it was interesting for me because I actually got to take my code base from IronPython and move significant parts of it over. We were already working on Visual Studio tooling, so that moved over, and I got to take my code base and go join a new team after having my job eliminated.
Oh, wow.
Yeah.
So IronRuby is in the community right now, but it's just kind of not doing anything, right? So, like, I wouldn't want to bet my whole company on IronRuby.
I wouldn't bet your whole company on it, but there are still people contributing to it. In particular, Tomasz, who was the lead developer on IronRuby, he still contributes to it. He's working on things like getting it running on Windows Phone 8 and other platforms like that. So,
oh, wow.
Yeah.
So that means I might want to use that for scripting or integrating existing Ruby code with stuff that I'm doing in .NET.
Yep. Yep. And in fact, I think IronRuby is further along in its support for the different profiles running on Windows Phone, running on Windows 8 than IronPython is actually. And that's due to his efforts.
Okay. That's pretty cool.
Yeah.
Okay. Now, when I look at the IronPython Codeplex page, ironpython.codeplex.com, it says current version 2.7.3, and it has a date of 2012. Which might lead someone to say, oh, that's dead or done or on pause. But if I go to Python tools for Visual Studio, which is pytools.codeplex, it's like a hotbed of activity. What is the difference between those two things?
So IronPython does have a more recent release, but it's a beta release. So 2.7.4 beta is available, but you're just not going to see it on the main site as the prominent download. There's also IronPython's activity. If you look at Codeplex, you're not going to see a lot of activity there because it's actually all hosted on GitHub. So when we release the languages, before they were in silos, where IronPython source code was hosted on Codeplex and Ruby's was over on GitHub, but internally we were all in one source repo, and we would push out to the various places the things that we needed. And we knew that wasn't going to work for the community because there were shared components between them and they needed to be developed together. So when that went out, everything moved to GitHub as far as source control goes, so you can see some actual activity going on there. Mm-hmm. PyTools, on the other hand, we do have 4 full-time developers working on it, and so there is a lot of activity on PyTools, and we host the entire thing on Codeplex, so you'll see our source commits and our issue tracker, and it's all there, so you're going to see a lot of activity there. As we during our releases, we will not be pushing sources very often, but as we get more and more stable, we just start pushing individual bug fixes, and we're about to turn the corner there. And so you can go to our source code tab, and you'll see commits basically every single day. Mm-hmm. And so it does look very active.
So explain to me, as an ignorant person who used Python in school, the difference between CPython and then IronPython. I can spend a bit of the podcast at the beginning here. We're talking about Iron this and Iron that. These are all implementations of languages on .NET. But CPython is what Python programmers use. So it seems like Python tools supports multiple engines. It's like pluggable. So explain the differences.
Yep. So IronPython is the version that's running on .NET, and CPython is, not surprisingly, the original version that is implemented in C. There's other implementations. So there's implementation called PyPy, which is Python that's actually implemented in Python. And that might sound completely crazy, but they have this entire tool chain which actually produces a JIT-compiled Python implementation that is implemented in Python. So you can take that implementation, you can run it just as a Python script, or you can go through this massive compilation process and get this runtime that is super, super fast and specializes code like crazy. And PyPy even, there's other languages that run on top of it now as well. There's Jython, which is yet another implementation, which is Python running on Java. Mm-hmm. That was also done by Jim Huguenin originally, and it was originally called JPython back then. So there's a bunch of different implementations. They all kind of have their sweet spots, right? So IronPython and Jython, they're great for integrating with your runtime environment if you're a Java or a C# developer, for extending those environments, letting your users script your application, things like that. CPython also gets embedded in applications a lot. Civilization 4 had a huge amount of scripting code that was written all in Python, even though the core app was written in C++. And you can there's various boost bindings to call into Python easily. Not that it's very difficult to do it just from C by hand. Mm-hmm. And then PyPy is kind of for speed fanatics, where they need to get every single bit of performance out, but it's also still a little more experimental than the other implementations. So we support all of these. In Python tools for Visual Studio, we have our own parser, and we typically talk to a Python implementation just over a socket, right? So our debugger, it's very easy to implement a debugger in pure Python itself that is intercepting the function calls, and you can stop execution for a while. And so there's just standard APIs that support that, and so our debugger is written in Python, and we communicate with the Python process over a socket. So if your Python implementation supports sys.setTrace, our debugger can debug you. There are some features that we kind of specialize. So we have profiling support that is CPython specific, just because we have a instrumented profiler, and we want it to be as fast as possible. So we're talking to the C API directly. But we have our own parser. We analyze the code all without executing code. We have a REPL window, and it works the same way as the debugger does, in that we're just talking to a Python process over a socket and sending information back and forth. So we're very Python interpreter agnostic. And you can just bring whatever Python interpreter you have and use it.
Yeah, it's interesting. There's a little Python interpreters toolbox in Visual Studio that lists all the different ones, and you can switch back and forth and make them the default. It's almost like, just to put it in the context of people who've never done anything like this before, imagine if you could plug in different CLRs. If there was more than just the main CLR and mono, if there was like 5 or 6, and people were just bringing out different ones all the time, and you might pick and choose a runtime interpreter as just like you pick and choose a pair of pants.
Yep. And, if you're targeting multiple Python versions, that, it starts to become very useful to be able to switch between those quickly and easily, and, make sure that your code's working on Python 2.7 and then switch over to 3.3 and make sure it works there as well. And that new interpreters window is new in 2.0, and we also have virtual environments, which are new. And that's kind of like the same concept, but on steroids, where instead of just having these core interpreters that are installed, you can do all sorts of customizations on top of them and have different sets of libraries that are available in different interpreters.
Mm-hmm. And how did you guys pull this off, though, such a small group of people? That's the thing I'm kind of trying to get my head around. There's how many people worked on this?
So this project actually has a very long history. It came out of IronPython when we were working on IronPython tools for Visual Studio. But the code base has pieces that go back for a pretty long time. So in 2005, the VS SDK team used IronPython as a sample in the VS SDK. So that's kind of the very first piece of Visual Studio integration that ever happened. Then after that, and that kept getting updated along the way. At some point, there was a project that we called Nessie, which was using the Visual Studio 2010 editor bits, which hadn't shipped yet. That was yet another internal project that was before it got into Visual Studio, and we were trying to do a standalone IDE with that stuff, where we were using the editor bits and plugging it into Python. And so some stuff survived out of that effort. Later, we had an effort called Boston, where, again, we were kind of using those same VS editor bits, but we were actually trying to do all of the coding in Python itself, in IronPython. So we were hosting the VS editor in this Python app that was written in Python, so trying to build a Python IDE entirely in Python. And that's kind of when our analysis engine initially got wrote. And there was yet another effort to plug into VS 2008 at one point, which we called Iron Studio, and we were actually looking at doing both IronPython and Iron Ruby at the same time. And so we built upon what's called MPF Proj, which is the project system that everyone builds upon when they're doing Visual Studio development and they want to plug in a language. And there's a bunch of common stuff shared between the two, and a bunch of that code continues to live on. So and then we did IronPython Studio finally, and that saw the light of day. We released it at PyCon, I want to say 4 years ago. So you can see that's a pretty long history already. And then after IronPython was canceled, we started Python tools for Visual Studio. And so that kind of sucked in all of these assets that had been building up over a very long period of time. And so I was initially the only developer on that, and then eventually we got a tester, and the team has been growing. And now with 4 people and a very solid foundation to build upon, we're able to move pretty quickly.
What does the Python community think about this? Like, Microsoft's, I came to work here to help make things better, right? And I don't like the whole Microsoft is evil thing. Even when our group isn't evil and other groups are evil, it's frustrating. But when you go on stage at a Python conference and you go, hey, this and that and the other thing, are they like, boo, you suck? Or is it more about the love of the language?
So the Python community has been nothing but supporting throughout my entire time that I've been working with Python at Microsoft. I go to PyCon every single year. I think I've only ever heard, one sort of spiteful comment to my face. Maybe everything gets said behind my face, but they're very embracing. We are supporting the language, and we are not going out and tinkering with it and doing evil. Even with IronPython, we are very careful to make sure that what we are doing with the language was the right thing and that we weren't embracing and extending it. I think there's only one language difference in IronPython versus CPython, which is you can do foo.none, and in CPython, none's a keyword, and in .NET, none is used in enums all the time. And so it was just a compromise where, okay, we'll let this one little edge case slide through so that people can use .NET in a reasonable way. And other than that, we were super true to the language. And, we would work with the CPython test suites. We would write our own test suites when they were inadequate. And, we just wanted to nail it. And I think people recognize that. And with Python tools for Visual Studio, there's obviously less of a corrupting influence that's possible because we're just kind of consuming the language. But at the same time, we try to take it to new places, and I think people appreciate that.
Yeah, one of the things that I was a little surprised about, and I think that you should talk about, is when you hear about stuff like this, you assume that because the non-Express SKU version of Visual Studio is the only one that supports extensions, that this would require Pro or Ultimate. But you're actually not using Express, Pro, or Ultimate. You're using something called VS Shell.
Well, you can use the integrated shell. You can also plug into Pro and Ultimate, and there's benefits to that too. But the integrated shell, we ship that for free. It's a little confusing. There's something called the isolated shell and the integrated shell. And in order to install the full shell, you have to first install the isolated shell, and then install the integrated shell on top of it. And then you can go off and install whatever plugins you want. But basically, it's a blank canvas of VS. It has no built-in language support, so there's no project types when you start off. But once you drop in other plugins, you can start doing all of your development with that plugin.
Well, you described a list of things that sounded complicated, but I'm looking at the PyTools website, and it says, I don't have VS and I want free Python. There's one thing to install.
Yep, so we made that really simple in this release. In the past, we told people to go off and install A, B, C, and then you have everything you want. And with this release, we now have the integrated installer that just brings that it has everything in it. It's a 400 megabyte download, but you can just save that and install it, and you've got Python tools for Visual Studio for free. That's
pretty crazy. Is there like a boss who will say no at some point? Like, why don't we charge people $99?
So there are advantages to going to Pro, and those are kind of the same advantages that you see with going to Pro with other languages. So VS has some features that don't ship with the integrated shell, and those include unit testing, which we just added support for in PTVS 2.0, and profiling is also not available. And then there's also just kind of the mixed language scenario, which I think a lot of people want to do with Python as well. If you're doing some technical computing scenarios, frequently you're going to have to drop down to writing some C code if you're doing CPython. If you're a .NET developer, typically you're interfacing with some C# code. And so getting a solution where you can work with multiple language types, that's just not possible with the integrated shell because we don't ship a C++ plugin for the integrated shell or a C# plugin. And now we have mixed mode debugging, which kind of makes this even more compelling. So if you have a C plugin for your Python code, you can create a solution in Visual Studio. You can have your C extension module in there and your Python code in there, and you can start debugging. You can just step from your Python code to your C++ code or vice versa. So there are some really compelling scenarios when you upgrade to Pro.
I have to admit, I've done C and C++, I've done Pascal, I've never written Python for money, but the extent of my mixed mode debugging skills has been, and by mixed mode, I mean doing more than one language in one solution, was Pascal calling C back in, 20 years ago. But when I explained this mixed mode debugging, some people were freaking out. Like, they're like, this is the most compelling thing ever. Who are these people who would care about that?
So lots of people need to get every bit of performance out of their Python code that's possible. So they'll start off, they'll be prototyping their code in Python initially, and they'll figure out the right algorithm, and then they'll want to rewrite a portion of that algorithm, the inner loop, in C code so that they can avoid things like boxing. So in Python, every single integer that you allocate is an object, and it involves a memory allocation, and so if you're doing a tight loop, things like that are pretty slow. So mixed mode debugging lets you, or writing C extensions lets you rip out some of the Python code and make the slow parts really, really fast. And that's been encapsulated for a lot of things. There's libraries like NumPy and SciPy, which have a huge number of algorithms, things with, matrices and other things. There's lots of graphics libraries that are out there. And so if you're just consuming the library, it's probably not too interesting to you. But if you're actually developing one of these libraries, the ability to look at both sides of the world and just step from one to the other, it's not, I'm debugging my C code and I, figured out what's going on there, and so now I have to stop and restart and build up all of my context again, and then go and work on my Python code a little bit. You're not bouncing back and forth between those two worlds. You're just in both of them at the same time.
Why does this blow mine so much, though? Like, is this really hard or not a common thing, or are most people who are doing this kind of work and aren't using Python tools, are they just like doing got here debugging with like debug.log?
All of those things are true, I think. It is really hard. The CLR has had mixed mode debugging with C++ and C# for a very long time, but it's not perfect the way it's implemented. The CLR has this debugger helper thread that's running in its process that's there and being used to help do your debugging operations, whereas a C++ debugger typically wants to stop your entire application. And while it's stopped, it can poke around at data structures, but code's not running inside of it. And so the helper thread is working against that. Python, our debugger, works the exact same way. We have a helper thread that's running. So the first thing that you have to solve is how do you debug your runtime environment without having any code running inside of it. And so that is a difficult thing to do alone. And in Python, it's really difficult because almost every single debugger is implemented in the style of having a debugger helper thread. And so, we have to go off and look at tons of debugging symbols for Python and drill through the data structures and basically recreate what the Python runtime would do for us very easily. So there's that technical challenge. Then there's the technical challenge that the VS debugger team solved, which is coming up with an architecture for this stuff where you can have a bunch of debuggers that are working together and working together nicely. And they solved that problem in VS 2012 in a very elegant way with something that's called Concord. I'm not sure if there's a better public name for that, but we talk about mixed mode Python and C++ debugging, but you can actually mix in C# or JavaScript debugging with that as well. And you can have a call stack that spans all of these different languages, and it just works seamlessly. So that's a very difficult problem. People have done things where they've taken like GDB and they are running their program in Python. Python has a command line debugger called PDB, and then you layer GDB on top of it, and you get an experience that's similar to this, but having it all integrated together and having it just look like your normal debugging experience requires so much stuff to come together and work nicely. So it's a pretty tough technical problem, and I'm a little surprised that we were able to pull it off.
When did Visual Studio get good at this? Like, was it 2012, or when did we? Because, I mean, I don't know. I've been in Visual Studio since 2003. So what is that, 10 years plus? And, for a while there, it got quite a bad name, and there are still people who feel that it's too fat for what it does. It's too heavy. But then it seems like in the last 3 or 4 years, it got really good at becoming a language factory, a place for doing stuff like this. I know that Mads Christensen's VS Web Essentials, he has found the editors and language services really, flexible once you learn the magic underneath them.
Yeah, I think it's been over, starting with 2010, I think, VS really started changing and becoming a lot more extensible and a lot more friendly to people who are extending it. So VS 2010 took a bet on MEF, and so now they took a large bet on managed code as well, where you have a large number of interfaces, which are just so quick and easy to extend using MEF. You can just export an interface and it gets picked up magically, and you're not dealing with COM anymore, which is always painful. It's hard to discover things. MEF can be a little bit hard to discover things. It's still very interface driven, but the APIs are so much simpler and cleaner and nicer. So if you want to go off and write a classifier for your own content type in Visual Studio, it's pretty easy. You just implement this I classifier provider and hand off classifiers to VS, and you just walk your text and report back the various classifications to it. And defining new classifications is super easy too. You just implement a class that has some attributes on it, basically. And so it becomes much more declarative and much simpler to go off and extend. And then there's the new editor that got implemented in VS 2010. The mixed mode debugging stuff all got rewritten in 2012. And it's just, they've been building and building more and more new, easy-to-use interfaces. And if you go back and compare it to, you use the term language service. And it's kind of interesting. The language service is slowly kind of disappearing from VS. There used to be, there's this IVS language info interface, I believe it's called, which was kind of the heart of your language service now. And now it's not quite gone yet. We still implement one of those for Python, but all of the details that used to be handled by that thing are off somewhere else now, using much cleaner, nicer interfaces.
The last question here is, what group are you in? Like, who is the boss who is paying for Python development?
I am in the cloud tools team. So, one of the things that we do with PTVS and in general on our team is features related to the cloud. So a feature that I didn't mention, I probably should, is our new support for Windows Azure websites in PTVS 2.0. So now you can do file a new project, you can make a Django application, you can right-click on it and publish, and we'll go ahead and send it up to Windows Azure for you.
Django being a very popular web framework for Python.
Yep, exactly. And so, we've done other Django integration in previous versions. We've had cloud service support, so you could take Django, deploy it to a VM running in the cloud. We've done things like the Azure Client Libraries, which let you manage Windows Azure itself, and you can spin up VMs and other tables and services, and you can insert data into tables and all of those things. So each release, we kind of, not only are we focused on just making a better Python IDE, but we're also focused on making that IDE work really nicely with Windows Azure too.
That's pretty sweet. I really appreciate you taking the time to chat with me today.
No problem. It's been a lot of fun.
So folks can check this stuff out at pytools.codeplex.com. I did a big blog post on Python PTVS beta. All of this stuff is free if you want, and like Dino said, if you've got Pro, you get even more stuff. So check it out. This has been another episode of Hansel Minutes, and we'll see you again next week.